This is Zhonghua Xu from Virginia Tech. Today, my presentation is investigating the dynamics of geospace environment from Antarctica, a two-dimensional magnetometer array. And I would like to thank all the collaborators domestically and internationally. This is a collective effort. So why we need this two-dimensional magnetometer array in Antarctica? The reason is we need to study the spatial weathering impacts globally. And an important part of that is the interhemispheric comparison. A showcase here is a Sato et al. 2013. And for the same aurora substone, you can see the aurora pattern are different in the northern hemisphere in S-line and versus the southern hemisphere in Showa station. Their localized patterns are different in both hemispheres. So we cannot just assume from one side of the observation or mechanisms on one hemisphere is the same as the other one. So we need to have observation and study in both hemispheres. So is that the case now? No. Showing by James Weygand is equivalent currents with 2D network. Here's a showcase. On the left is a disturbance in 2016, March 20th. The magnetic activity and solving conditions showing here. And here, the big circle, you can see this is the northern hemisphere equivalent currents. With multiple observation available, you can see a clear pattern of this equivalent currents generated, developed through the whole disturbances. But it's really hard to see the pattern, the development, the impacts in the southern hemisphere due to lack of observation. That's why we need this two-dimensional array. Now, how we get this array? Through international collaboration. So firstly, we built the East Antarctic array along this 40 magnetic meridian, which is magnetically conjugate with the DTU West Greenland magnetometer chain. Then through collaboration with BAS and other international collaborators, we extended the new station towards the aurora zone. Also, we collaborated with the Chinese Antarctic Research just to put in two new stations here, the black dots, along the Zhongshan Dome A PG1 South Pole station. So now we have station in both latitude and longitude. We have this two-dimensional array available. Here's the instruments we have at this station. We use something called Autonomous Adaptive Low Power Instrument platform, LPIP. On LPIP system, we have fluxgate magnetometer, induction magnetometer, case dual frequency GPS receiver, and HF radio experiment. And the data are available at a website like listed here. And here's a showcase of the PC5 wave we found during a case on 25th of January 2016. This is a very rare case because this is solstice condition. One side of atmosphere is in winter, the other is in summer. So the asymmetric condition of ionosphere conductivity. But you can see very similar frequency of a surface wave in both hemispheres, northern hemisphere in black color, southern hemisphere in red color, and propagate all the way from aurora zone location to polar cap. And this is very rare. It's showing although the conductivity is different, but they can have similar frequency wave generated. Another thing shown here is the IP shock and the ground magnetic field response. On the left is a typical inclined IP shock. The angle of impact is 42 degrees. And then you can see after impact arrive at Earth, the northern hemisphere and the southern hemisphere show totally different response. But on the right is a frontal shock, which is a 1.5 degree. You can see the response in both hemispheres is very similar, both frequency, pattern, phase, and intensity. So that's the research we can do with the expanded 2D network of Antarctic magnetometer through autonomous instruments and international collaborations. And all the data are available at mist.nia.org and also a variety of other websites. Thank you.